Welcome back to Ember Training. In this module of training, we're going to talk about some more ZigBee concepts that revolve around common network activities. These include things like joining, forming, and building out the network. So let's begin where the network begins, and that's with creating a network. When a ZigBee network starts, it all begins with the ZigBee coordinator, the ZC. So this is shown in our diagram, if you remember from our last presentation, with a thick red circle. The thin red circles are the routers, the thin blue circles are end devices. So the coordinator begins by choosing some kind of channel, which would be one of the 2.4 gigahertz allocations, designated 11 through 26. So these represent channels with a center frequency of 2.405 gigahertz all the way up to 2.480 gigahertz. And then the coordinator is responsible for choosing a unique 2-byte PAN ID as well as a unique extended PAN ID. So if you recall from our last presentation regarding PAN IDs, the short PAN ID is generally what's used to divide up the network, but in case it comes into conflict, the extended PAN ID is kind of our backup. So really it's the extended PAN ID that distinguishes who's in one network from who's in a different network. The shorter PAN ID is mainly used as a common over-the-air identifier to allow for filtering of messages that come from other networks. So once the coordinator is chosen, this channel, its PAN ID, its extended PAN ID, using whatever criteria it needs to do that, then from that point the network grows by allowing a router or an end device to join through the existing coordinator. So the basic idea here is that a device can't get into the network except through a node that's already in the network itself. So other than the coordinator, who has this special property of being able to instantiate a network or form the network without having to get permission from anyone, the end device or the router has to be within range of another device so that it can ask that device, is it okay for me to enter the network? So the router or the end device enters into the network through some existing node, in this case the coordinator, and then future nodes can join either through that coordinator or through the newly joined router. They cannot join through the end device because the end device doesn't support the ability to route. And so as we do this, we start to get a kind of tree-like structure that builds out, with the coordinator really being in the center of the network and the rest of the network growing outward from that, with the end device generally being on the fringes of the network, hence the name end device, because it's at the end of the trail here. Now viewing it from the other perspective as far as joining, if you're a device that wants to come into the network, embodied by this purple circle in my diagram, neither red nor blue yet because it hasn't actually joined the network, so technically it doesn't have a node type, the device has to scan across the channels first of all to decide, okay, what networks are available, and then it has to solicit router and coordinator nodes, but not end devices because we can't join those. It has to solicit those router or coordinator nodes to determine what networks are there and which are available devices through which we can join. So the process by which we do this is called an active scan. This is an IEEE MAC concept, an 802.15.4 specified concept, where we send what's called a beacon request, which is a single hop broadcast that transcends all the PAN ID boundaries, meaning every device in every PAN on every 15.4 network within range can hear this beacon request, and they're supposed to respond. If they're a router or coordinator and they hear this, they would respond with some indication of their network, which means their PAN ID, their extended PAN ID, and in ZigBee there's this notion of a stack profile or stack feature set, meaning ZigBee or ZigBee Pro. So they provide that information as well, and then a Boolean parameter that says whether or not there's any joining allowed by the device in question. Now this joining allowed property is done on a case-by-case basis for each node. So it may be that there are two nodes in the available network, but only one of those nodes actually is allowing new devices to enter. So it's something like having multiple access points into the network where they can be enabled or disabled for accessibility to new devices at will. The other information that's not displayed in my diagram here is there's also some information back from the router or coordinator about its ability to sustain additional end devices. So that if it's an end device asking, the parent might say, well, I could let you into the network if you were a router, but because I can't support any more end devices and you want to join as an end device, then you need to know that I don't have any room left for end devices. And that allows the end device to rule out that node as a particular parent. Okay? So, in this diagram, we see the large arrow soliciting the devices with its beacon request, and the individual network indications or beacons coming back. Whichever beaconing device is heard better, that's the one chosen for the potential parent in the network that's chosen. So the application tells the device, I'd like to join network A, and the stack says, okay, given A1 and A2, A1 sounds a little better, I have a better link, I'm going to try to join through A1. Once that's chosen by the joining device submits an association request or a join request to the device in question from the chosen network. So that's the number 2 action here, the arrow going across to the chosen device. And that device will make sure that it has enough room to accommodate a new end device if the incoming device wants to be an end device. So at this point, there's no security authentication really. It's simply, if I submit a join request to a node and it has enough capacity for me if I'm an end device, and the device I'm asking happens to permit joining at this time on a local level, then it should create a random address, send it back to me, and now I'm successfully associated into the network. So this process of association is really a very simple one-to-one device process and doesn't really involve contact with other nodes. Now, when we discuss security in a later presentation, we'll discuss the rest of the story here, because after the association takes place, there is some authentication that needs to happen here with the Trust Center device. Examining this further with respect to Ember's implementation, for a node that's already in the network, it's typically going to be calling the Ember permit joining function with a given duration of a number of seconds that says this device is going to allow new devices to associate through it into the network for this many seconds. If you're the device that's trying to come into the network, you're looking for a node that's recently done a permit joining action, so it's permitting new devices. So we have a utility function in the EmberZNet library of utility code called EmberScan for joinable network. And that function takes a mask of channels and then a desired extended PAN ID. So if the device coming in already knows exactly which network it wants, it can restrict the results by an extended PAN ID criteria. If it doesn't know that, it can just pass all zeros for this field, and it'll just simply return all available results. So scan for joinable network is called, and for each network that happens to permit joining, those things will come up in the joinable network found handler. And the application will get to mediate the results and decide which of those networks it's interested in possibly joining. Now at that point, the application is going to call Ember join network on one of those networks. The networks are embodied in a network parameter structure. So you pass a pointer to this structure of network parameters, and it's at this time that you supply the node type. So until Ember join network is called, the stack has no concept of what node type, router, coordinator, end device, sleepy end device, mobile end device you want to be. So it's only when this call is made that the stack begins to take on the role of this node type. Assuming all goes well, then you should get some indication that the join succeeded. So you get into this network, hopefully, and because all the criteria that you have to really go on for selecting networks is mainly this selection of random PAN ID and random extended PAN ID and a somewhat arbitrary channel value, because that's not usually enough information to decide which network is the right network, a lot of times you're going to have to go through this iterative process of guess and check. You join network A, you do something to decide is network A the right network for me, or maybe the installer does something to check this. And if it's not the appropriate network for whatever reason, then either the device leaves or the installer takes the node out of the network. And if you determine all this within a 30-second period, you can use EmberScan for next joinable network, which says, I've already ruled out this first network. I'd like to move on to the next results. So go assess the available joinable networks again, but only give me a joinable network found handler for networks that I haven't tried lately. And so if you continue this process with no more than 30 seconds between calling the scan for next joinable network function, then it ensures that any network that you've tried and already ruled out is going to be blacklisted. So you won't attempt to join the same network over and over and over simply because it's the first result. So that's how we go through this process of finding networks to join, joining the networks, and then cycling through to the next criteria. So other network activities that can occur. If you are the coordinator, you are not going to be calling Ember join network because you can't technically join to anyone yet because there isn't anyone to join. So you're going to instead call Ember form network. And Ember form network is forming a new PAN, which means by default you become its coordinator. For the purposes of security, you also become its trust center, by the way. Another activity that's maybe not as straightforward is something called network init. Network init is something that relates to the EmberZNet stack, where all of the network criteria, including security criteria, the PAN ID, the channel, the node type, even its network ID information that it obtains as it joins the network, is all stored in non-volatile data. So this is useful because if the device were to ever reset unexpectedly, you would want to retain all of your network settings and be able to recall that to come up right where you left off and not have to recommission the entire network simply because of a brownout. By default, most applications that we provide as samples are crafted to come up and call network init right away. After initializing the stack, they want to resume their place in the network. So rather than go off and form a new network or join a new network, most devices, as they come up from a reset, will want to try to call network init. And if the stored information from the last runtime is valid, then that information will be restored, and hopefully the node can get back on the network. The only case where it might not do that is if it's an end device who can't find its parent any longer. If you're an end device, you must have a valid parent. So if you're an end device, you call network init, it is possible to get to a state where you are technically associated to the network, but you don't have a parent. And at that point, all you can do is really rejoin. But for a router or a coordinator, doing network init essentially means coming right back and resuming your place on the network without having to get any permission, because that's already been taken care of in a previous runtime instance. So let's talk more about this rejoin activity. If you are an end device who's lost your parent, or you're an end device who doesn't like the parent connectivity that you have, or you're a mobile node who's woken up in some strange location and needs to reassociate to a new connection in this network, or maybe you're just a router that has lost connection to the rest of the network because maybe the network changed channels or changed PAN IDs and you missed it. So whenever that happens, you can call Ember find and rejoin network. So whenever the application wants, find and rejoin network can be called, and if the device is actually remembering its settings, then it can go out and search the available channels. So you provide a channel mask to this call, and it'll search those channels and try to get you back onto the network that you were in before you called rejoin. So even if the security key has changed, even if the channel has been moved, even if the PAN ID has changed, because the extended PAN ID never changes, the rejoin concept works because the device can go out and do these active scans and look only for those networks where the extended PAN ID is a match to the device's own extended PAN ID. And because this is a rejoin, meaning you've already gotten acceptance into the network once, you ignore the permit joining stated devices for this purpose, because you've already been approved. So this is typically, as I say, used for end devices that lose connection to the parent device, because this will find them a new parent during this process. And that ends our discussion on common network activities. So we've seen how networks are formed, and we've talked about the form network API. We've seen how devices join the network, and we looked at the join network API. We talked about resuming our place in the network with the network init API, and we talked about reconnecting to the network when our connections have failed using the find and rejoin network API. So now you know a bit about the network activities. I'm Matt Dibb, and I hope you learned something.